Hi, my name is Michael Pendazis, and this is the problem homework. This is the test review for test number 3 for Math 241, Probability and Statistics. Let's get started. I need some pens. So, markers. Okay. Good. Okay. So in chapter 6, so we're going to look at these homework problems here to help us review for the test. So we're going to look at the homework problems in chapters 6 and 7. So in 6.1.4, pages 182 to 183, there's exercises. This is 6.1.4, pages 182 to 183, there's 1, 3, and 9 there. And so let's look at number 3 of this section. Okay, so for number 3, it's find e of x if x is, so you should open your book and look at this. Find e of x if x is the sum, ax is the sum of the two rolls of the die. Okay, x is the sum of two rolls of the die, and we're going to find e of x. Find the expected value of this discrete random variable. Okay, so the possible values of x could either equal, the die, right? The die has these possible values. Die has values 1, 2, 3, 4, 5, and 6. And so the possible values of the sum are 2 through 12. Right? So the possible values of the sum of two rolls of the die is the smallest it could be is 1 plus 1, the largest could be 6 plus 6, and has all the values in between. So the possible values of the sum of two rolls of the die are from 2 to 12. And so what is the probability of each sum? Well, so let's make a table. Now on the left, I'm going to put values of x, the sum of the two rolls of the die, and here I'm going to put f of x, which is the probability of getting that sum. And so the values are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so the probability of getting a sum of 2, well, there's only one way to do that. If you get a 1 both times, so that's 1 out of 36. There's 6 possibilities for the first roll, there's 6 possibilities for the second roll, so there's 36 total possibilities between the two rolls, and only one of them you can get a sum of 2. For a 3, you could either get a 1 or 2 or 2 or 1. So there's 2 possibilities. So that's 2 over 36. 4 is 3 over 36. 5 is 4 over 36. 6 is 5 over 36. 7 is 6 over 36. And then it goes back down to 5 over 36. 4 over 36. 2 over 36. 3 over 36. 2 over 36 and 1 over 36, and let me just check to make sure this adds up to the right number here. So that's 21, 26, 30, 36. Good. So these are the probabilities of those values for the sum of two rolls of the die. And so e of x, the expected value of x, is the sum from x equals 2 to 12, the sum of overall possible values of x times f of x. And so that's going to be 2 times 1 over 36 plus 3 times 2 over 36 plus 4 times 3 over 36 plus 5 times 4 over 36. And you see where I'm going with this, and this will be plus dot 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 plus 12 times 1 over 36. And you multiply all those things and you add up the products and you get e of x, the expected value of that discrete random variable. Okay? Right, so you multiply each of these corresponding things and you add up the products and then you get your final answer. And so that's the expected value of that one. Okay? And so there's a part B, but this is another problem similar to this. And so let's keep going. Okay, so the next problem is page 190, so it's 6.2.3. And it's going to be exercises 1, 2, and 5. And this is page 93 to 95. Page 193 to 195. So let's look at number 1. Okay, so for number 1, it says if player A plays player B $1, so A pays B pays $1. Pays $1 to B when the outcome of a roll of one die is 1, 2, 3, 4, or 5. Okay, so when we roll a die, if it's 1, 2, 3, 4, or 5, A pays B $1. Now, B will pays A a certain amount when the outcome is a 6. And we wonder, what is that, the amount that B should pay A, so this is a fair game. Okay? And so the definition of a fair game, right, is a game such that E of X is equal to 0. Right? So, right, so the expected value is 0. And so we need to find the expected value of this situation. And so I'm going to call this C. And so B is going to pay a little C dollars if a 6 is rolled. And so let's find the expected value using C, and then we'll find the value of C that makes the expected value 0. So E of X is the sum from X equals 1 to 6 of X times f of X, where X is the outcome of the roll of a die. So here's the die, and so the possible values of X are 1, 2, 3, 4, 5, or 6. And so then we're going to take each value of X, which is 1, times f of 1, but don't forget the probability of each X is 1/6. Probability of every outcome of the roll is 1/6, so it's 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. And so if you multiply all those numbers and add up the products, then you get 21/6, which is 3.5. Okay? So the expected value here is, sorry, not sorry, I have to fix that. It's not that. The probability is 1/6 for each of them, but the value X is the amount. X is the amount B gains from the game. Okay, so that's the X we're considering. And so the probability, right, so the probability is still 1/6 for each roll, but so when you have so here we go. Okay, so the possible values of X are the amount that B gains from the game. So either X is, right, so the possible value of X is either 1 or C. So B either makes $1 or I'm going to call, okay, so instead of putting that, I'm going to say that C is the amount B gains. So it's going to be like the negative of it. So let's roll with that. Okay, so X is 1 or C. So then f of X is going to the probability that B gains $1 is going to be 5/6 if X is 1. And so there's a 5/6 chance that B will make $1 because there's a 5/6 chance he'll roll 1 through 5 instead of 6, and A will have to pay B $1. Then there'll be a 1/6 chance if X is equal to C. C is the amount that B is going to gain by paying A. So C is going to be a negative number. So B is going to lose C, amount C. That'll be a 1/6 chance. Okay, so now let's fix that. So X is going to go from X, these are over all possible values of X, and so this is going to be X is 1, and that'll be a 5/6 chance, and then X is C, and that'll be a 1/6 chance. And so if you add that up, you'll get C plus 1 times, you'll get 5 plus C over 6 is the expected value. And what we want that to be is 0. We want the expected value to be 0. And so what we want is for this E of X, which is this, to be 0. And so that means C is going to have to equal -5. In order for 5 plus C over 6 to be 0, the numerator 5 plus C has to be 0, so C has to be -5. So B is going to gain -$5 if you roll 6. That's what we want. And so B is going to pay A $5. That's our conclusion. That's the answer. So the answer is that B pays A $5 here if you roll a 6, and that's what will make this a fair game. That's what will make the expected value 0. Okay, so let's keep going. Next problem. Okay, page 199 to 200. 6.3.2. Exercises 2 and 5. Okay, so this is page 199. So problem number 2 is I'm going to let X be a random variable with this probability function. Okay, so it's going to be 0.1 for X equals 1. It's going to be 0.4 for X equals 4. And it's going to be 0.5 for X equals 9. And so what you want to find is E of X squared, and there's two other ones here. There's E of X squared, there's E of X to the 1/2, and E of 2X to the 1/2. So let's just do one of them. So let's find E of X squared. So E of X squared is going to be the sum over all possible values of X squared times f of X. Okay? And so then this is going to be, well, the values are these three are the possible values of X, so we're summing over those values of X. So we're going to get 1 squared times f of 1 plus 4 squared times f of 4 plus 9 squared times f of 9. And so f of 1 is 0.1. That's 1 times 0.1 plus 16 times f of 4, which is 0.4, plus 81, which is 9 squared times f of 9, which is 0.5. And so this is 0.1 plus 0.64 plus 40.5. And then so that's 41.24. So this is 41.24. So E of X squared is 41.24. Okay, and so that's number 2, and in this section. And so let's keep going.